So I made my own solar panels. I'm making my third solar panel right now. This is my second one, and I think it's out of the two, this is my best. If you check out this diode right here, this is called a blocking diode. This is the positive side. You can see the wire coming from the bottom of the cell. It attaches to the diode, and that is the thoroughfare side, so the power will go out, but power will not go in. Therefore, when a battery is connected up, it won't bleed back toward the cells on the shady portion of the day, thereby losing power off your battery. That's what the blocking diode does for you. Now, you can see from here that if you follow the right side up, it goes all the way up to the top, comes over, comes down the middle section, meets this side, and then goes back up to the top. These are all in line, or you would call it in series. This cell or solar panel would make up 18 volts at 1.7 amps. These are Everbright solar cells. They normally come 3x6. I would have made this twice as wide as it is right now. This is a 1x4 cell. I would have made it a 2x4 cell using the full-size solar cells. I didn't want to do that because that would have used up too much of my patio, so I bought 3x3 cells. If you look up this, they were making 3x3 cells. They were saying they were having problems with their laser for cutting the cells, and they may not be economical for them. You may not be able to buy 3x3 cells. However, you will be able to buy the 3x6 cells if you decide to make your own solar cells or solar panels. On the bottom of each panel, I used a outdoor or an indoor electrical outlet that goes on the outside of your drywall. I took out the electrical outlet portion, basically gutted it, screwed this to the bottom of my panel, and thereby creating my junction box. And I simply went to an electronics store with a bar that has the screws in it so that I could connect from my solar panel, and then from my solar panel the wire goes to my power control box. This is a solar panel that is made up of 3 parts. It has the frame on the outer side, it has a glass top, and then it has the solar panel below. This white material, and then I'm pointing at right here, this backing material is simply a compressed paper product. You can buy it at any hardware store. It's a 1/4 inch thick. And then below that I have another one that's a 1/4 inch thick, and I have the wood routed for the glass. So the glass goes inside right here, and then I'm going to caulk this section here. Don't caulk inside the wood and make it very tight, because the wood will expand and contract and it will break your glass. You just want a bead that goes on the outside to prevent water from coming into your panel. You don't want water going inside your panel. You don't want condensation or anything like that, so you want to seal it the best you can. So what I would do is I would put caulking on the bottom and sealant on top, so that you have a nice sealed system where water vapors can't get inside and cause condensation on the inside. If it does happen, I could take the whole panel off and I'd clean the glass, but I don't want to have to go through doing all that. In the long run, if the wood becomes rotted or old or warped or whatever happens, because I have this sitting on top of another backing, this whole section can be removed. I could build a new frame and then reuse this whole solar system. I made this so it's reusable. I thought that would be a brighter idea than just making it a one-time use thing where if things screw up, you can't fix it. Also, if let's say one of these solar cells busted, I'd remove 2 of these cells and then I could resolder these in. I would scrape the silicone off of the bottom, because that's all I did is I put silicone on the bottom of each one of these. I started right here with laying this one down, and I had all 12 of them holding up in a row, and I put silicone on each one of the cells, and then I laid these cells down. And then I moved them around, made sure that they were lined up, and then I did the next row and the next row, and then I put the glass in, and voila, your solar panel that is removable and fixable. With every solar panel you're going to need batteries. Batteries are the heart and soul of any solar system. It's the only way that mankind knows how to store electrical energy. Okay? Now, in the back is a ProStar 30 power controller. That will make it so that your battery will never be overcharged or undercharged. It keeps it charged at the right area. Right now, the yellow light indicates that the battery is about half full. The green light indicates that it's charging. Looking at there from left to right, the left section is where the solar panels come in. The middle section, the four connectors for the battery. So you can basically have two 12-volt batteries hooked up into that area, which will allow for 24-volt system. And on the far right is the load out. You can see the way the batteries are hooked up. I have the positive right there. I have a negative connection right there to a positive connection, and then I have my negative connection out. The red wire and that black wire right there go through to my inverter, which gives me 120 power for doing my 120 household connection. And basically that's all there is to it. I have a 1000-watt true sine inverter, which is the best kind of inverter, and it will run my 40-inch TV. It's not running it right now. My son is watching it while I'm making this video.